Hello and welcome to another math video for grade 10. So in this video, we are going to start section 2 of chapter 8 with the topic of angles of rotation. The purpose of this lecture is to somehow generalize the definition that we had earlier for trig ratios in a right triangle. So if you remember, we defined trig ratios for acute angles, because in any right triangle, except for the right angle, the other two angles are acute angles, and so we define trig ratios for those acute angles. But in most cases, we need to define trig ratios for angles more than 90 or 90 itself, right? So we cannot just make do with right triangles. We need to define trig ratios for any angle, not just necessarily acute angles. So that's why we are going to generalize that in this lecture. So in order to achieve that goal, we need to have some definitions first. The first one is about angles of rotation. So let's just read this and then I will explain this in detail. Angles of rotation are formed in the coordinate plane between the positive x-axis, which we call them initial side, and a ray, terminal side. Positive angle measures represent a counterclockwise rotation, while negative angles indicate a clockwise rotation. So let's see what is this all about. So remember, in general, in geometry, we have if you have two rays that have the same vertex, the same common vertex, that defines an angle for us. So if you have a vertex with two rays starting from that vertex, that defines an angle. So that's the very definition of an angle in plane geometry, right? So that's one example. The other example could be something like this. So that was an acute angle, this one an obtuse angle, right? So two rays with a common vertex will define an angle for us in plane geometry. Now here we are forced to put that angle in the coordinates plane. In order to do that, we have to come up with some standard definition for an angle. So the standard definition that we have goes like this. Let's say you have a coordinates plane like this one. I know that the shape is getting messy, but in a moment I will erase this. Just for the moment, bear with me. So we say an angle in the coordinates plane is in a standard position if, first of all, its vertex is right at the origin. So the vertex is right at the origin over here. Remember, we need to have two rays, right? So the vertex is at the origin. One of the rays is fixed on the positive x direction. So one of the rays is always in this direction. So it is always fixed here. As you see, it is aligned with the positive x direction. We call this ray, which is fixed on the positive x direction, we call it initial side, the term that you see over here. So that's initial side of my angle. And the other ray of the angle could be anywhere. So it could be on any quadrant of this coordinates plane. So it could be in the first quadrant, it could be in the second quadrant, it could be in the third quadrant, or it could be in the fourth quadrant. So the second ray, which we call terminal side, the term over here, could be on any quadrant of my coordinates plane. All right, so let me get rid of these extra rays. So let's just say we have this one. Now this angle defines an angle in a standard position because its vertex is at the origin, one of the rays is on the positive x direction, and the other angle doesn't matter, and the other ray could be anywhere. So this is an angle in a standard position. Now, there are two ways to measure this angle. Well, one way is to start from the initial side, from this side, and then go counterclockwise until you get to the terminal side. So I go counterclockwise until I get to the terminal side. So if I measure my angle in this fashion, then the angle that I have over here is counted as positive. So counterclockwise will give us a positive angle. The other way that I can achieve this angle, I can describe the angle, is the other one. If I I start with the initial side and then I go clockwise until I get to the terminal side. So it could be this angle, right? Now this angle is considered to be negative measure. Okay, so if I go clockwise, it gives me a positive angle. If I go counterclockwise, I'll have a negative angle. And the point, if you look at this shape over here, you see an angle. If I count it as counterclockwise, it gives me a positive angle of rotation. And on the other hand, this shape over here, I measured it clockwise, and that will give us a negative angle of rotation. That's all there is to it. So if you go clockwise, you'll get a negative angle. If you go counterclockwise, you'll have a positive angle of rotation. So let me erase these extra shapes over here, and then let's see the other slide. So here I gave you 3 examples of angles. The first one, all of them, look at all of them. They're all in a standard position. The vertex is at the origin for all of them, and the first ray is aligned with the positive x direction, and the other ray could be on any quadrant. So the first example, the terminal side is on the second quadrant, and I counted counterclockwise. And the angle that I have here is positive 135. If I wanted to measure this clockwise, then I would have gotten this angle, which gives us a negative measure. Okay, so this one, terminal side is on the third quadrant, and that will give us a positive 210 measure for this angle. The third one, terminal side is on the fourth quadrant, counterclockwise measure, and that will give us a 300 degrees for this angle. So notice that here, for this particular shape, for this particular angle, if I go clockwise, I'll get this angle, which will give me negative 60 degrees. For this one, if I take it clockwise, that will give me negative 150 degrees, right? Because they have to add up to 360. And for this one, if I take it clockwise, then this angle would be negative 225 degrees. All right. Now that we know what is an angle in a standard position, now let's define trig ratios for any angle, for any general angle. We are going to generalize the trig ratios that we had earlier in the previous video. Okay, so before I come to this one, to this generalization, let me give you a very particular angle, which is an acute angle in a standard position. So let's say you have an angle like this in the coordinates plane. So that's my usual Cartesian coordinate plane. And I have an angle in a standard position, so the initial side is over here, and the terminal side, let's say, is like this here. Okay, so I have counted as a counterclockwise angle theta. All right, I'm going to define trig ratios for this angle. By the way, this angle is an acute angle. So how did we define this before? You can pick any point on the terminal side. Pick any point. For example, like this point. Let me write with orange color. Yeah. So let's pick this point on the terminal side. So that point has coordinates of x and y. So it has x coordinates and then y coordinates. It's a general point on that terminal side. Well, now you can make a right triangle with that point, right? If you come down like this, you'll make a right triangle with a right angle over here. So in this right triangle, I can define sine, cosine, and tangent as before, right? Now, the length of this The length from the vertex from the origin to this point over here, well, is obviously the x-coordinate, and this length is y. That's the height of this point, and the hypotenuse in this case is, if this one is x, that one is y, is what? Root x squared plus y squared. That's the Pythagorean theorem. But for the moment, let me just call the hypotenuse here, let's call it r. So this one is x, and this one is y. Now let's write down the trig ratios that we'll learn in the previous video. So what is sine of angle theta? Sine of angle theta is opposite divided by hypotenuse. So in this case, opposite is y, right? Opposite to angle theta is y, and the hypotenuse is r. Okay, so sine theta is y divided by r. What is cosine of theta? Well, cosine is adjacent divided by hypotenuse. Adjacent in this case is x, and hypotenuse is still r, so x divided by r. And tangent of angle theta equals opposite divided by adjacent, so which is y divided by x. So these were trig ratios that we had in the previous video for acute angles. We will generalize this exactly in the same way for any other angle other than acute angles. So in this case, in this shape here, you see an angle in a standard position. So that's the initial side, and that's a terminal side which lies in the second quadrant. Okay, and so that's the standard angle, counted as counterclockwise, which is positive measure. So let's pick a point, any point on the angle, like this one. It has x and y coordinate. Now we define the trig ratios for this angle in the following way. So we define sine of the angle to be y divided by r. R is the distance from the origin to that point. Much in the same way, we define cosine of the angle to be x divided by r. So this number, the x coordinate of the point, divided by the r, which is the distance between this point and the origin. And tangent, we define y divided by x. So this is the generalization of the trig ratios in a right triangle now for any angle. So pick a point on the terminal side. It doesn't matter where the point is, just it has to be on the terminal side. And then that point has x and y coordinates. Sine will be this, the y coordinate, divided by this distance. Cosine is x coordinate divided by this distance. And tangent is this number divided by this number. And that's it. So this works for any angle now in the coordinates plane. Let's see an example for this. So the point -2 and 5 is on the terminal side of an angle theta. Find all three trigonometric ratios for this angle. Let's draw a picture for ourselves and see what's going on here. It's not necessary to draw a picture, but that will help us to see better what do we have. So let's say we have a coordinates plane like this one, x and y. Point -2 and 5, so if that's -2, 2, 3, 4, and 5 will be about here. So that's the points -2 and 5. So this point is on the terminal side of the angle theta. So I have an angle in a standard position. So the initial side is this. And this point lies on the terminal side. So the terminal side has to go through this point. So it's something like this. Okay? And that's my points, -2 and 5. And the angle is this one. See, I don't know exactly what the angle is. All I want here is to find the trig ratios for this angle. So I want to know what is the sine of this angle, cosine, and tangent. So I don't care what is the measure of this angle. Let's just use the definition to find sine of this angle. I need to divide. So sine theta was y divided by r. And remember, r is the distance from this point to the origin. That's the distance. Okay? And cosine of the angle was x divided by r. And tangent of the angle is y divided by x. To find tangent, I don't need to know what is the radius, what is the distance. Just simply divide 5 by -2 and that's it. But for sine and cosine, I need to find r first. So let's find r. Well, we have to use distance formula between 0, 0 and -2 and 5, and that's easy. Distance equals -2 squared is 4 plus 5 squared is 25, and that will give us root 29. So that's the rate. That's the distance. That's r. So therefore, sine of the angle equals y, which is 5 divided by root 29. That's sine of the angle. Cosine of the angle, x divided by r. X is -2 and r is root 29. And tangent of the angle is y divided by x, which is 5 divided by -2. I just pulled the negative up and I put it here. -5 divided by 2. And that's it. That's how we found the trig ratios for this angle in this example. So just notice here that you can always rationalize the denominator in this case. You can multiply up and down by root 29, and in that case you can rationalize the denominator, but I'm just gonna go ahead and leave it in this form for this example. And that's it for this video. In the next video we will cover more examples and more concepts for trig ratios.